Welcome back. In this session, we will discuss about history of data warehouses and its drawback. And also we will get insight of data lakes and its drawbacks too. Let's start by looking at what a data warehouse is. The data warehouses came into existence in 1980s, when businesses wanted to make decisions based on all the data available in the organization in one place rather than looking at the data in individual departments. A data warehouse mainly consisted of operational data available within the organization. Some large data warehouses also gathered external data to make intelligent decisions. The data received in the data warehouse is mainly structured as delimited files such as CSV or semi-structured, such as JSON or XML files. They didn't have the ability to process unstructured data. The data received then goes through ETL or extract transform load process and stored in a data warehouse or a data mart. The data loaded into the data marts are cleaned, validated, and also augmented with business meaning. Also, they are generally highly aggregated to provide meaningful business value, such as key processing indicators or KPIs. This data is then consumed by analysts or business managers via BI reports. The data warehouses were very valuable for making business decisions, and most large companies had at least one data warehouse by the early 2000s. At the same time, they had some significant issues. In the early 2000s, due to the popularity of the internet, the volume of the data started to increase significantly, and also the variety of the data had started to change. We started to see unstructured data such as videos, images, text files, etc., and they were very valuable for making business decisions. Data warehouses didn't have the ability to handle them. In a data warehouse, data was only loaded after the quality of the data has been checked and also once it has been transformed. This meant it took longer development effort to get any new data into the warehouse. Data warehouses were built on traditional relational databases of massively parallel processing engines or MPP solutions, which meant they used proprietary file formats and had vendor lock-in. Also, traditional on-prem data warehouses were very difficult to scale on, nearly impossible. This meant large data migration projects were required in order to scale up those databases. Storage was expensive with these large vendors, and also it was impossible to scale up storage without compute. Finally, data warehouse didn't provide sufficient support for data science or ML and AI workloads. So here comes the data lake. The data lake architecture was aimed at solving the issues we discussed with data warehouses. They came into existence around the year 2011. Data lake can handle not only structured and semi-structured data, but they can also handle unstructured data, which is roughly 90% of the data currently present. The data received is ingested directly into the data lake without any kind of cleansing or transformation. This resulted in quicker timescales to develop solutions as well as faster ingestion times. Hadoop-based HDFs as well as the cloud object stores such as Amazon S3 and Azure Data Lake were really cheap, so organizations could ingest all of the data without worrying too much about the cost, which is great. The data lakes were built on open source file formats such as Parquet, ORC, and Avro, which meant that we could use a wide variety of software and libraries to process and analyze the data. The data science and the machine learning workloads could use the raw data as well as the transformed data in the data lake. But there is one major problem. Data lakes were too slow to service interactive BI reports, and there was lack of governance for the data in a data lake. So the industry moved towards copying a subset of the data from the data lake to the warehouses again to support the BI reports. This resulted in a clunky architecture with too many moving parts and duplication of data in the lake and the warehouse, resulting in additional cost and management. These issues brings the need for a modern data warehouse, which brings together the data lakes and the data warehouses. Most cloud vendors are trying to solve this problem, and it's still evolving. For example, Databricks are trying to solve it with the help of Delta Lake and Microsoft with the help of Azure Synapse Analytics. Amazon, Google Cloud, and Snowflake are also coming up with their solutions. We are going to focus on implementing the solution using Azure Synapse Analytics in this course.